Mhm. Bismillahirrahmanirrahim. The talk is about natural language processing. An introduction in half an hour. I will try to introduce important concepts, important uh, 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 methods for natural language processing. So first, let us start why we learn natural language processing. So natural language processing is the processing of natural languages or human languages like English, Urdu, Arabic, German, Chinese. Natural language processing, there are many major applications of natural language processing. For example, search engine that has semantics. So if you search computer, it should also show you laptops. If you search tables, it should also show you desk. And so it should deal with semantics. Another application is sentiment analysis and other text classification tasks. I will come on their detail at the end of the presentation. Machine translation, translating Urdu to Arabic, Chinese to English, and other languages there. Then question answering system. You ask computer a question and it replies you. It gives a reply by consulting its database, its knowledge base, etc. And usually we do not consider optical character reader and speech processing in natural language processing. It is mostly based on text analysis, because writing analysis and other thing, it involves image processing. Speech processing is another issue. So usually natural language processing involves uh, dealing with text. So if we are processing speech, first speech will be converted to text, and then NLP system will be applied on that text. So how people do natural language processing? What are different techniques? The There are two major techniques. One is linguistics and linguistic analysis, and the other is machine learning. And machine learning has its own techniques, for example, bag of words and sequence to sequence. So we will focus first on linguistic analysis, then we will go to machine learning. So what is linguistic analysis? Linguistic analysis is also called, or was also called, deep method. It is in comparison to the shallow method of machine learning or text mining, in which we do not go into the details. But this deep method is different from the modern concept of deep learning. Deep learning are neural networks. Deep method is the deep analysis of text. It is inspired by linguistics. So what we usually do in deep method or in linguistic analysis, we convert text into tokens. So if it is written inspired by linguistics, it has 3 tokens inspired by in linguistics. Then tokens are converted into part of speeches. Then we apply morphology on it. So we can see it by an example. So linguistic analysis, an example of linguistic analysis is, we have a sentence, good programmers are coding in Python. So first task would be tokenization. Good will be 1 token, programmers would be the second token, coding would be the fourth token, Python would be the 6th token. Tokenization seems simple, but it has many problems. For example, New York. Is New York two tokens, consists of 2 tokens, or it is 1 token? Natural language processing, are they 3 tokens or they are only 1 token? And I have a longer presentation. I will share it with you. It had 80 slides. This presentation is 20 slides, so it is better to be discussed in 40-minute slot. But I will share the other thing, and it has detail of issues in tokenization. So tokenization is an issue. We decided that coding is a token. Then we apply other linguistic concepts on it. What is the root word or lemma of coding? It is code. Either we have a list of a dictionary of all tokens and their lemmas. For example, coding, the lemma or root word of coding is code, lemma of rote is right, lemma of new is no, or we apply some shallow method, for example, stemming, and we chop up ing, ed, s coming at the end. So if we apply stemming, it will be end on chord. Or if we apply lemma that uses list of words, it will be resulted as code. Then we see what is the part of speech of word coding. It is verb. Then morphological analysis. Okay, it is verb, but it is verb in progressive form. Then syntax. So good programmers are coding in the Python. So programmers is the subject of this sentence. So good programmers write good code. So programmers is subject and code is object. So after analyzing on the word basis, we analyze the whole sentence and we decide which is the subject, which is the object, and which is oblique and other things. Then the next step is semantics. So good programmers are coding in Python, they like it. Both programmers and they are agent. And Python is programmers is agent. Both programmers and they are the subject, but programmer is agent because it is acting on something. They like it. They is not acting on something. They which is महसूस कर रहा है. So they is experiencer. So in semantics, we have to find what is the semantic role, or actually what the person is doing. So it can be agent, it can be experiencer, it can be instrument. And if we say it is liked by Python is liked by the programmers, by the programmer will not be the subject, but even in this case, programmers will be the agent. Then we apply co-reference. So programmers are coding in Python. First sentence is understood. But the second sentence is they like it. Who is they? So they is linked with the programmers. It is the co-reference. They and programmers are co-references, and it and Python refer to the same thing. So in some text we have to find what does these pronouns mean, what does they means, what it means. They like this language. So what is this language? This language is pointing to the Python. So it is co-reference analysis, and we have to do it in some examples. Then one example is named entity recognition. If we have nouns, we have to define whether they are person or they are organization or they are places, dates. So there is one Python example. If we have a sentence that Sarfraz Ahmed, the wicketkeeper batsman, has been retained as Pakistani captain. So it will, when in this sentence, Sarfraz Ahmed is person, Pakistan is GPE, geographical or political entity, Sri Lanka is geographical or political entity, Pakistan Cricket Board is organization, PCB is is also organization, September 23 is date. So named entity recognition involves extracting type of the nouns from a text. And if it has Pakistan Cricket Board and PCB, we were referring to co-reference analysis. When we apply co-reference analysis on it, it should tell us that PCB and Pakistan Cricket Board are the same entity. So linguistic features, these linguistic features are used as features in many machine learning systems. So they have an old system and practically they are rarely used now, in which you apply linguistic analysis and the system solely work on those linguistic analysis. But practically in modern system, we apply linguistic analysis and these linguists, and it create linguistic features like these. And these features are used in machine learning systems. So there are two systems, linguistic analysis and machine learning, and both in practical, for all practical purposes, we use hybrid of those systems. Then we come to Many current and old systems use linguistic analysis. However, modern trend is end-to-end system. I will return to end-to-end system when we will be discussing sequence-to-sequence analysis. So, linguistic analysis, what I earlier said, has we can apply linguistic analysis by two methods. One is rule-based system. The other is by using machine learning systems. So example of rule-based system, if we want to implement morphology, we have to design transducers. They are a special kind of finite state automata. So we have to design transducer for nouns, transducer for verbs, transducer for adjectives, etc. For subject, for finding subject object, we have to design context-free grammar, then attributed context-free grammar. So these are rule-based system in which the designer should know morphology of that language. If I want to work on Chinese or Arabic, I should know morphology of Chinese or Arabic, or I should know context-free grammar of grammar of Arabic and Chinese. Then the other system is machine learning system, and machine learning system are two, can be supervised method or unsupervised method. So in by right, it is possible that we write rules that verbs end with at ed and nouns and at s like this, or we can learn these rules. So machine learning systems have uh, are used. There are two kinds of machine learning systems: supervised machine learning systems and unsupervised machine learning systems. Supervised machine learning systems use annotated corpus. Unsupervised will be discussed in, I think, at the end of the presentation. But in supervised machine learning system, we need annotated corpus. So first, what is corpus, and then what is annotated corpus? So annotated corpus is a large collection of text, and large means it should have billions of words or at least tens of millions of words in it. So corpus is collection of raw text. You go to the website of Dawn or Jung or New York Times and download all its data. You go to the Facebook profile of your Facebook profile and your friend's Facebook profile or Twitter account handle and download all their posts or their tweets. This is the raw corpus. Then comes the annotated corpus. Annotated corpus is more difficult to get because you have to annotate or annotate each and every word on it. For example, if we want to make a part of a speech tagger, we should have a raw corpus, and then for every word we have to write whether it is a noun or it is a verb or is it an adjective. For a grammar checker, grammar parser, we have to write whether it is a subject, whether it is an object. If it is a subject, what is its verb? If it is a verb, then what is its object? So we have to define all these things by hand. So annotated, and when we get annotated corpus, we give it to the supervised learning algorithms, what we learn in machine learning, the classification algorithm, and it generates a linguistic analyzer. So if we give part of speech annotated data to it, it will generate a part of speech tagger. If we give dependency structures or grammatical structures to it, then it will generate a grammar parser and so on. If we give named entities annotated corpus, it will generate a system that tag named entities. But annotation has problem. Most of the applications now are created in this way, but annotation has these three major problems. First is annotation is time consuming. You can download 1 million words within seconds or within minutes, but you cannot annotate 1 million words within a month. So it takes a lot of time to annotate corpus. More than time, it needs linguistics in model. Everyone wants to make NLP systems. Everyone wants to make named entity systems or information extraction systems. And many students and many companies have started annotating their corpus. But the problem is that corpus is not good annotated. Most of the systems available right now that are shared on GitHub and other other websites are not good annotated because you need to learn one semester course to annotate something. It is not the case that a student says, I will make a part of speech tagger, or I will make a uh, grammar parser, and next week he or she start annotating the corpus. He or she must learn linguistics, basics of linguistics. So linguistics skills are required. And the thing is repetitive tasks become boring. So first is you have to give time, then you have to learn skills, and then even if you have both of these things, it becomes boring after 2 or 3 days. If you are annotating regularly 3 hours daily for 1 week, you will get bored. So these are the problem with annotation, and this result के बहुत बुरी एनोटेशंस भी अवेलेबल हैं, बहुत अच्छे, जिन्हें बहुत अच्छा रिसोर्स माना जाता है, वो उनकी भी क्वालिटी बहुत अच्छी नहीं होती. So it is linguistic analysis. Now, if we cannot become a linguist, can we do natural language processing without learning linguistics, without learning what is part of a speech, what is verb, what is past tree? So it is possible in many cases. So non-linguistics method, there are two major non-linguistic methods. First is bag of word approach, and the other is modern approach of sequence modeling. Bag of word approach, if we say that it says that order does not matter. And in sequence modeling, order does matters. So bag of word approach is applied in text classification, text clustering, and topic modeling. What is bag of word approach? So we represent text as numbers. So we convert our text into numbers. Usually frequency of each word becomes a number, a feature, and its value is its frequency. So every word becomes a feature, and its value frequency in that text becomes uh, its value of the feature. So representing text as number. The assumption is that there is no structure in the document, so a word that comes at the start of the document is as much important as a word that comes at the end of the document. Subject और preposition का object equal important है. अच्छा, सब्जेक्ट वर्ड्स को अगर सेंटेंस को हम टॉगल कर लें तो उससे कोई फर्क नहीं पड़ता. तो स्ट्रक्चर, देयर इज नो स्ट्रक्चर इन डॉक्यूमेंट और सेंटेंस. और only thing that is important is word count. So every word becomes a feature, and its count or frequency becomes the value of the feature. And then when we have feature vector, we apply standard machine learning techniques of clustering, classification on those vectors, and then we can make a classifier. So for sentiment analysis, first we have to convert every message into our feature vector, and then we make a classifier that learn what are the positive feature vectors and what are the negative feature vectors. Another application, so bag of word approach is finished. Classically, it was very successful. First, spam filter is used using text classification, and until recently, before the arrival of neural networks and deep learning, text mining is done using bag of word approaches. Search engines practically uses bag of word approaches. Spam filters uses bag of word approaches. Sentiment analysis uses bag of word approaches. Another important thing is word embedding. So word embedding is used to model semantics. So similar words have similar embedding. So the major problem in bag of word approach is, or in all of the classical approaches, is that every word is a unique symbol. Laptop is laptop, computer is computer, chair is chair, desk is desk, table is table. We cannot find that laptop and computer are similar concept, and desk and table are similar concept. Everyone is a different concept. Even we have singular plural, computer and computers, they are two different concepts. Computer and computing, they are two different concepts. So we have to introduce semantics somehow. There are many methods of semantics. WordNet is available. Last to last talk was about semantic webs. So you can create ontologies about some domain. So here you can make rule-based system or hand-coded knowledge-based systems are available. But word embedding techniques is involves extracting semantics from raw corpus. You have a raw corpus of millions of words, and you extracted semantics from it. So if it converts every word into a feature vector on the basis of their neighbors, and words with similar feature vectors, the words which are neighbor in the vector space have similar semantics. So there are many tools available, just like, for example, word2vec, fast text, Elmo, in which you can give raw text to these tools, and then you can generate feature vectors. For example, this is processing of Urdu raw corpus. The most similar words for Suraj are Chand, Suraj, Aftab, Mahtab, Tare. So Suraj, Seen Wow Regime, and Suraj, Seen Pesh Wow Regime are two different words for computer. So it learns that Suraj and Suraj are used in similar sense. Otherwise, we have to write a text normalization system that strip all the diacritic marks. And you can see that if we draw these vectors in 2D space, Shumal, Mashriq, Maghrib, Junub are neighbor to each other. Shumali, Junubi, Wasti, Mashriqi are neighbor to each other. Pakistan, Hindustan, Bharat, America are neighbor to each other. There are two alternate spelling of America, America and with alif and America with he, and both are close to each other. Otherwise, in classical system, we have to make normalization list many normalization list. America ending on alif and America ending on he are the same words. Bharat, Hind, and Hindustan are the same words. But modern word embedding system learns these things automatically. So word embedding systems, what is the unit of tokenization in word embedding system? It can be word, a single word in word2vec. So in word2vec, if we consider the word tokenization, word2vec will say it is a single token. Character in fast text by Facebook use character engrams. So we can tell fast text to make tokens of up to up to four characters. So TOKE will be one token, OKEN will be second token, KENI will be third token, and the semantics will be learned of the collection of all these tokens. So character based engrams we can use, or we can learn unsupervised morphology learning. We can learn morphology by ourselves. So there are two major tools, Morphessor or byte pair encoding. You can provide a raw corpus to Morphessor, and it will learn that these are the root words and these are suffixes or affixes. For example, it can learn that book and table are the root words, and s come as a suffix to these things. So these can be learned. So it can learn that tokenization has more than one unit. Token is one unit, za is other unit, shan is other unit automatically. And these Morphessor and BPE are used in modern sequence to sequence system, especially in BERT like systems. BERT is coming in the next thing. Okay, and one research direction, if anyone want to go in this direction, is that morphology. All of these tokens consider morphology as a sequence of characters. So if we have kitab, we put ye nun gunna at the end, it becomes kitabe. We have books, and we put s after it, it becomes books. But if we go into Arabic, the plural of kitab is kutub. So we have to remove alif from inside the token. Mulk become mamalik, we have to insert meme before meme and alif inside the token. So infixation, prefixation and suffixation is dealt easily, but infixation is very difficult. And template-based morphology of Arabic and other Semitic language is very difficult to deal by these methods. So it is an open question to develop a fast text system that works on Arabic or template-based languages that try to make a n-gram of first letter, fourth letter, and sixth letter. First letter, second letter, and fourth letter. But it will blow up the computation. So without blowing up computation, how can we model template-based morphology of Arabic? Then we come to the modern era that is started 5 years ago of sequence modeling using deep learning. So bag of word approaches says that order doesn't matter. Cow eat grass or grass eat cow are equivalent in this in bag of word approach. But in sequence modeling, cow eats grass is different from grass eats cow. So order does matters in sequence modeling, and there are many tools recurrent, for example, recurrent neural network. The good thing is about is that it provides us end-to-end solution. End-to-end solution, we do not want to if we are going to make a machine translator. Classically, machine translators are made first by converting words into tokens, then provide their part of a speech. One is a analyzer part that analyze their part of a speech, then tree is created and tree is converted to other tree. But it is end-to-end solution. We gave examples of example sentences in English and their equivalent in French, or English sentences and their equivalent in Urdu, and machine learning system learns how to make features out of it. So we do not have to give part of a speech tagger to this system or a parser to this system. Even it is tried that you do not need to provide a tokenizer to it. So if I can give a whole string I space am space a space student full stop, and machine learning system itself can learn that I is one token, m is other token, student is other token. It is it seems straightforward in Urdu, English, but it is not straightforward in Thai language or Chinese, which does not use space in it, or in Arabic, in which if we say Bismillah base one thing and Isim is other thing. In al-aqwam, al is alag thing and aqwam is another thing. So tokenization is made easy by these things. Then in modern world we have BERT. So I think after sequence to there are many methods to deal with sequence to sequence analysis. Either we can convert an image to text. So the training set will consist of image and its description. So when we provide an image to it, it will convert it into a sequence of words or sequence of token. A cat sitting on the table. It can give a caption to a picture of cat sitting on a table. Or classification, we give a sequence to him that this product is wonderful, and it will give us a single output that is a positive. It is a positive sentiment. Or many to many, just as we see the part of a speech tagger that this is good, this is the part of a speech of this is pronoun, is verb, and good is adjective. Then 2 years ago, the modern state of the art is BERT, bidirectional encoder representation for transformers. It heavily it is a good example of transfer learning. So major problem in deep learning is that we do not have enough training data, because deep learning needs a lot of data. And if we want to make an English to Urdu translator, we need 1 million sentences of English and their translation in Urdu. Getting those sentences is very difficult. So a moderate system should have 1 million words. Otherwise, 1 million examples, and but we do not usually have that much data. BERT uses transfer learning to solve this problem. It has a pre-training model. In pre-training model, we train language on it. In layman term, we can say we give the same sentence at input and output, and it start learning the language. So we have a lot of monolingual corpus. We can download Dawn, Tribune, Washington Post, New York Times, all Twitter, all Wikipedia, and we can train a language model on those raw matter. And when we train language model, when then we add an adder and the last layer of a neural network on it that can classify it, make it classify it, can convert into a sentiment analyzer, or it can convert into a named entity recognizer, or it can convert into a part of a speech tagger. So it is of two steps. In first step, we train a language model using monolingual corpus, and we have built in for monolingual corpus we can have billions of examples, and then we go to tens of thousands of examples. We put a last layer on top of the pre-trained model, and make a sentiment analyzer or named entity recognizer or anything. There are 8 or 10 different tasks that can be performed by using it. Some are here, for example, translation, question answering system, sentiment analysis. What are modern topics of research? So ACL is the biggest conference of Association of Computational Linguistics. So it is biggest conference of natural language processing. In last 10 years, the major topics were pre-training. Pre-training is just what I described it for transfer learning. Pre-training, transfer learning, semi-supervised learning, distance supervision, and weak supervision. So these are the major issues. Word embedding becomes because it is easy to implement word embedding. It needs only raw corpus. So word embedding is a active research topic. Convolutional neural networks, recurrent neural networks, transformers is the modern thing, and sequence analysis is a general thing that involves both recurrent neural networks and transformers. So BERT is an example of transformation. Okay, but if you are going to for research in modern NLP, there are some issues or cautions we must focus on that. BERT is state of the art, and there are many state of art coming in these days. However, we have to focus the cost benefit analysis of state of the art systems. Should we apply BERT, the state of the art system, or we applied RNN, recurrent neural network system, or we apply bag of word approach? We have to deal with cost benefit analysis. What is the computational cost of a BERT based system, an RNN based system, or a simple bag of word based system? Because many modern systems, BERT and RNN, needs a lot of computational resources for training. They need GPU, they need cluster of GPU for 1 week, for 1 month, for 2 months. So a good system is trained on cluster of 4 GPU running on for 15 days. So should we go for this high computational cost, or we remain on bag of word approach that is trained within minutes? So cost benefit, if bag of word approach gives us accuracy of 95% and BERT approach gives us accuracy of 96%, do we buy a GPU and spend 1 month for its training to get 1% more accuracy, or we will remain on our laptop and simple bag of word approach? But the other issue, especially for academia, is prestige versus increase in accuracy. So businessmen can say, okay, मेरा सिस्टम थोड़ा सा कम काम करेगा लेकिन जल्दी काम करेगा। इन एकेडमिया प्रॉब्लम बढ़ गई है। पेपर रिव्यू करने के लिए भेजते हैं तो वो कहते हैं स्टेट ऑफ द आर्ट सिस्टम आपने क्यों यूज नहीं किया, चाहे वो स्टेट ऑफ द आर्ट सिस्टम 2 महीने रन करने के बाद और मिलियन बाल जगह पे इस वक्त मैं सर्च नहीं कर पाया, वरना शायद 70-80 लाख रुपए लगते हैं एक सिस्टम को ट्रेन करने में। तो आपने वो सिस्टम क्यों यूज नहीं किया? तो प्रेस्टीज होती है, आप बर्ट यूज क्यों नहीं कर रहे, आप RNN LSTM क्यों यूज नहीं कर रहे, आप वो 1970 का नाइव बेस मॉडल क्यों यूज कर रहे हैं? तो ये एक बहुत बड़ा इशू हो गया है कि प्रेस्टीज से का कैसे जवाब दिया जाए। एक्यूरेसी ऑन रियल डाटा वर्सेस टेस्ट डाटा एक और क्वेश्चन। बर्ट वगैरह पे बहुत सारी चीजें, खासतौर पे पैराफ्रेजिंग और इम्प्लीकेशंस वाली जो चीजें हैं उनमें, और इवन टेक्स्ट जनरेशन में जो उनका टेस्ट डाटा पे रिजल्ट्स हैं वो तो बहुत अच्छे आते हैं, जब रियल डाटा पे अप्लाई करें तो रिजल्ट्स अच्छे नहीं आते। उसकी बहुत वजह है। तो अगर कोई इंडस्ट्रियल सोल्यूशन पे जा रहा है या आप अगर किसी सोल्यूशन को यूज करना चाहते हैं तो पहले उसके रियल डाटा को यूज करके, रियल डाटा पे उसे टेस्ट करके देख लें, क्योंकि जो रिसर्च पेपर पे रिजल्ट्स आते हैं वो एक बहुत लिमिटेड डाटा, टेस्ट डाटा पे मौजूद होते हैं। वो उसे स्केल अप बहुत सारे केसेस पे नहीं हो सकता। बहुत सारे केसेस पे होता है, मशीन लर्निंग पे बहुत अच्छा होता है, लेकिन कुछ केसेस ऐसे हैं जिन पे वो बहुत अच्छा नहीं होता। तो ये क्वेश्चंस होते हैं सिस्टम बनाते वक्त कि आप अगर किसी से वादा कर रहे हैं सिस्टम बनाने का मॉडर्न टेक्निक्स यूज करते हुए, तो इन चीज़ों को पहले ध्यान में रख लें कि आपको क्या करना है।